Hi, this is Sarah Burke. This video is a demonstration of how to use the JMP add-in developed to find the top n solutions in an enumerated list. So we had a previous video explaining the methodology and how the algorithm works. The goal of this video is to show you how you can access it in JMP. So the code for this is developed as an add-in. The add-in is available for download on the JMP community page or the Science of Test website for you to download free of charge. To install it into JMP, once you've downloaded the add-in, all you need to do is double click on the add-in and it will automatically install in your JMP file program. Once it's installed, a window will appear, another window option within JMP labeled add-ins, and it will be listed as top n PFS, which stands for top n Pareto front search algorithm. So now I'm going to show you how to use this add-in using the application that I demonstrated in the previous video. As you recall, this application was in the Department of Defense, where the managers needed to identify the 4 most critical subpopulations in their stockpiles, and they had several criteria that they evaluated, so reliability, urgency, and consequence. And in this example, the larger the value, the more critical the subpopulation is. So again, this is simulated data, but here we have our column for index, which again just is an ID column, and then columns for each of our criteria of interest. So in this example we had 100 subpopulations and we wanted to identify the 4 most critical subpopulations from this list. Alright, so we're going to use this JMP add-in to help us come to a decision. Alright, so if we go to the add-in menu and select top n PFS, a new window will appear that allows us to set up the algorithm. So here are criteria. In this example, we're just going to use reliability and urgency. It is functional for more than 2, but just for illustration purposes, we'll use these 2. And then index is our ID column, just to help us keep track of subpopulations. And then click OK. Oh, by the way, there is a help menu. If you have any questions about other details, if you click this help menu, there are details about using this add-in and all of the plots and outputs for you to use. Alright, now let's click OK, and now we have a new window where we can enter in all of the options. Okay, so the very first step, and which is required, is to enter the value of n, where we want to extract the top n choices. So here we wanted to find the top 4 or most critical subpopulations in our stockpile. So here we set enter 4. Right, the number of layers you want to enter. Again, we recommend keeping this as the value of n, so I'm going to enter in 4 here. And here you want to identify is each objective optimized by maximizing or minimizing. In this example, the larger the values, the more critical the subpopulation was, so we want to maximize these. These are our phase 1 settings, so if you recall, this is our purely objective stage where we wanted to just identify the solutions in the layered Pareto front. Okay, so no subjective choices being made here. It's purely which solutions are in our layered Pareto fronts. We're going to use those to find our top n solutions. Okay, we can also select our phase 2 settings. So this is optional. The algorithm will work if you just want to find the solutions in your layered Pareto front. That's great. You can use the phase 1 settings and then run the algorithm, and it won't do anything in terms of phase 2. If you do decide to use phase 2, the first thing you need to select is the desirability function. So to be able to use to get output from phase 2, you have to select a desirability function first. So you can select either the additive or multiplicative desirability function. You could also select both and you will get 2 windows of output, one for additive and one for multiplicative desirability function. So let's just use the additive desirability function for now. And then you can select which plots you would like to have in the output. So I recommend actually selecting all of them. They all provide different and unique information. Okay. This is just a way to round the desirability function score to a certain number of decimal places. I wouldn't worry too much about this. And then you can select how you want to scale your criteria. So as I mentioned in the previous video, there are 4 options for scaling. So best and worst, when you scale between 0 and 1, it's going to just consider best and worst values from the solutions that are from phase 1, so in the layered Pareto fronts. You could select the best and worst from all of the original data set, so in this case it would be all 100 solutions, right? What are the best and worst values? Or if you wanted to have a little bit more control, you can identify or define the worst values or the best and worst values. So for example, if I click this option, now I have a new table where I can enter in best and worst values for each criterion, and that's what would be used for the scaling. Okay. For this case, let's just use the best and worst based on the values or solutions in the layered Pareto fronts. Okay, so we have all of our options selected. So if we click OK, we will get our output. Okay, so the first window, I'm just going to move this up here for the moment. We have 2 data sets identified. They're the same data set, but the one on the left identifies the solutions that are in the layered Pareto fronts only, so it has layers 1 to 4 identified. And then here in this data set on this side, it's the original data set, and for example, if we highlight a solution here, it will highlight over here, and so this has the original data set if we wanted to keep track of solutions that weren't identified in phase 1. Okay, the second tab provides all of our graphical output, which will help us come to our decisions. So here is a interactive scatter plot, so this you would always get in the phase 1 analysis. And so here we can identify the solutions in our layered Pareto front. So here's layer 1, 2, 3, and 4. And for example, if you hold this and hit shift, you can get all of the layered Pareto fronts highlighted to see what they look like. Okay, and then if you scroll down, you can get all of the plots that we talked about in the previous video. So here's our mixture plot, and so we have the weight on reliability and our index identified here. And notice that we're looking for the top 4 by weight. Here is our proportion plot. It's our stacked bar chart to identify the proportion that each solution was in the top 4 across all the weight combinations. Scrolling a little further down is the parallel plot. So again, this allows us to look at the trade-offs in terms of our criteria. So again, steep lines indicate large trade-offs for a particular solution, and the flat lines indicate fewer trade-offs. And then here is the synthesized efficiency plot to help understand the consequences. So if I prioritize a certain objective or criterion, how do other solutions compare to the most critical one? And this mixture plot, you'll notice, has this hover text, so if you highlight above it, it identifies what the synthesized efficiencies are for each of these criteria for any given weight combination. And actually, if you wanted to keep track of them, so for example, I hover, and then I can do a little thumbtack there, and now it'll just stay in that picture, just if you wanted to use it as a comparison. Okay. If you scroll further down, you see this n+1 comparison plot. Okay, so this would help you to evaluate, maybe I want to look at additional values of n. Instead of 4, maybe I want to consider a top 5 solutions. Okay, and that's it. You can use these graphical tools to help you make a decision, to help identify the top n items in your list. Thank you.